Hey everyone, Miss GoElectric here, and today I'm in Detroit, Michigan at the Battery Show and EV and Hybrid Technology Expo. And they have moved to a bigger venue this year, so let's go inside and find out the most interesting things that are on display. Let's go. This is our third year reporting from the show, and it takes a full day to explore it all. As you might expect, most exhibitors supply machinery, services, and parts which support the battery and e-mobility industries. This year, there were many electric motor companies showing off new products for a wide range of applications. For the first time, I noticed several specializing in axial flux. All right, I am here in the GoElectric booth and also now a sub-brand Modal Motors. But what caught my eye here was that it looks like you have some kind of axial flux motor situation going on, but maybe plus in this case. Is that correct?
That is correct. Some people call it a raxial motor, and it's similar to what Koenigsegg is doing with their dark matter motor, but yet we're less than half the cost and more torque. So about 1.5 times the amount of peak torque. Because typically other companies, when they make their motors, it's a very difficult assembly process. Our motor from day one was designed for manufacturing, designed for assembly, and it's designed to be made here in the U.S. In fully automated cells. So all American components. So our magnetic poles for our stator poles, they're made here in the U.S. The magnets, if we want to use magnets, we can get them here in the U.S. Ferrite magnets. We can also go completely magnet free.
And you're saying here in the US, so as far as when we talk about manufacturing, what's the cost savings looks like? Because we know that well, at least when I hear Koenigsegg, it sounds expensive. So can you talk about the cost benefits?
Yeah, because so our motors also don't use any back irons, so that's a cost in a motor. That's also where losses occur in a motor. So, for example, typically back irons can lose up to 53% of the motor losses in it. So, by not having a back iron, having aluminum housing like that, it's a very cost-effective way to build a motor because we have fewer parts. We have discrete motor poles with discrete rotor poles. The whole thing self-fixtures, self-aligns for assembly, and that's what makes us basically more cost-effective and more power dense, torque dense than any other motor type. The other thing is our efficiency. With that no back irons that I was talking about, we have a higher efficiency over the full torque speed range. Whereas other motor companies are focused on saying, well, I can get 96% at this one point, this one load. We basically say, forget that. We can give you a higher efficiency over the full speed range.
And so, well, for packaging wise and performance wise, what are you looking at with this type of product?
Well, typically we're about half the volume of other competitor motors to give the same torque. So when you look at it that way, you can say, okay, I can fit more room for other stuff. Or like in marines, you can basically have a motor in the water that has less hydrodynamic drag over it. And in a drone or an airplane, again, less air drag over the motor because you have a smaller housing to clear with the airflow. So there's just a lot more when it comes to packaging efficiency as well.
So, when are you bringing this to market?
We'll be showing the prototypes at CES in January in Las Vegas.
Well, I'm going to have to see you there, that's for sure. And where are you going to be producing this?
These are going to be here in Farmington Hills, Michigan. So it's not just made in USA, but it is made in Michigan.
And do you have a customer base already?
We have 3 customers already. Some are from Equad to a boat, a marine company, 450 horsepower motor. And then we also have some warehouse robotics and a lot of other little applications that are coming our way.
Incredible. Well, thank you for spending some time with us today, Michael, and we appreciate you sharing all about this new product you have coming.
Thank you for joining us. I appreciate it.
I carried on my search for standout technology, but it is exhausting. Many of the booths featured technologies which address problems which are not commonly understood. Some require a very high technological familiarity to distinguish from one another. Fortunately, most experts and engineers in the booths were more than capable of delivering clarity. Well, I'm here at Unico, and it's glad to see a familiar face. I have Don here, and Don, we've seen a ton of battery charging, discharging, and testing equipment throughout the show, but you have something fairly unique here at Unico, and you've been working on something that will help not only make the manufacturing process a little bit quicker, but also sounds like you have some affordability and some long-lasting lifetime for the batteries as well.
Yeah, absolutely. So we're really exciting to be able to showcase some of this new technology here. We've been in the testing industry for a long time, testing a lot of engines and e-motors as electrification has come up. We've kind of spread out and done a lot of battery testing lately, but what we're really doing now is moving into the formation area. So where we're really doing the formation of the cells, we're doing that initial charge of the battery cells as they're being manufactured. And what we're finding is some of the technologies that companies have introduced over the past few years with pulse charging and high current charging and discharge profiles also will help in the formation process to speed it up so they can also get more throughput out of their gigafactories, but it also seems to have a much longer lifetime on the battery pack. So instead of maybe lasting 12 years, the battery pack will actually last 15, 18 years in its first life, and then of course another 15 to 20 years in its second life.
So how does that happen? I mean, there's probably some sort of product that you have around here that is going to help with that facilitation, right?
Yeah, absolutely. So what we have over here is our new cell formation channels, which we call the BAT 350. And so this is actually a very high performance formation device. It brings in a common DC bus, so like 400 volts DC up to 800 volts DC, and then it controls the current out to the cells during the formation process. So we can do 300 amps on each one of these devices for 4 channels, and then this does the rapid formation that the study is now saying will actually extend the life by up to 50%.
So can you give us a little bit of briefing on like this pulsing technology and what exactly that means?
As the batteries are being recharged, the lithium ions have to go back into the anode. And, that process when you're doing a constant charge, like DC fast charging or a constant charge, the ions have to distribute themselves in the substructure. And by doing this pulse charging, what they found, for this rejuvenation process in EVs, this allows them to kind of get some more life in the battery pack because it spreads out the lithium ions on the anode substructure. What we're looking at is also doing this in the formation process, because one of the big steps in formation is this rest period between charge profiles. It's several days to up to a week. And if we can use these pulses during this formation charging, then maybe that we can reduce this down by 30 or 40% to speed up the formation process.
I think when you say that not only does it optimize manufacturing, but it also means that the batteries last longer for customers, then this is all a win-win, because that is really what people are looking for, not only for the life of your EV, but also that second life application.
Yeah, exactly. So, really, if we start looking at these battery packs that are lasting 12, 15, 18 years in its first life, which in its first life still means it has 80% of its life for its second life in an energy storage system. Now we're really looking at battery packs that are going to live 50 years before we need to recycle them. So it's really exciting, and it's really game changing for the industry.
That's exciting. Yes. Well, thank you for spending some time with us, Don. We really appreciate it, and best of luck at the rest of the show.
Great. Thank you.
This year, there were countless companies exhibiting with a focus on the equipment required to get battery factories up and running. As we've reported on our weekly EV news show, The Current, on the Miss GoElectric main channel, there are over a dozen battery factories being built in the US right now. All right, everyone, I have stopped by the Zeta booth here because something caught my eye. This is Michael. He's going to tell us about what they have going on here and what kind of products they offer, because one thing in particular is I saw carbon nanotube anode, and that sparked my interest.
All right, so carbon nanotube anode. Yeah. So what we do, this is kind of an alternative, to graphite. And you know that 90-something% of the battery guys here, they're using graphite.
Yeah.
So we came up with an alternative. It's really simple, and maybe I can just point your attention down to here. So what we do is, we're using a standard copper foil. It's the cheapest copper foil we can buy, electrodeposited. So then we take this copper foil and we coat it with a catalyst. And I call the catalyst kind of like the fertilizer. And there's a really thin layer of this fertilizer or this catalyst on there. And then we expose the whole thing in a reactor, a so-called CVD chamber, and we actually insert some greenhouse gases, methane. So we're using methane to grow carbon nanotubes. And so this is now, if you compare that to graphite, this entire process of growing these carbon nanotubes is taking us less than 30 seconds. And it's also done at about 600 degrees Celsius. That's it. So now compare that with graphite, where you have to process the graphite material for 3 weeks at 3,000 degrees Celsius. When I heard it the first time, I also thought, I don't buy that. So I did some research and found out that's what they really do. This is just to get to the graphite. And they still have to then coat it onto the copper foil. They have to calender it. They have to do all that stuff. And here with us, it's these 3 steps done.
Interesting.
You're finished, huh? And we have our carbon nanotubes. We can grow them to the height that we need. And then why we need the carbon nanotubes? The carbon nanotubes, they actually host the lithium. So the lithium is coating these individual strands of carbon nanotubes. In this way, we create this gigantic surface. And we need this surface, so that the amps or the current per square centimeter or millimeter is super low compared to a lithium metal battery. So we don't have dendrites. So with this thing, we solved the dendrite issue. We're using greenhouse gas, so the CO2 footprint is rock bottom. And it's a very, very safe technology. Very, very safe. So this is just the anode. Now, if we go into the cathode side, what we're using here is we're using sulfur that we get out of a refinery. And there's about 130 refineries in the US. All of them, as a byproduct, as a waste product, they're producing sulfur. We're using this sulfur here, and you can see maybe the slightly yellow color. So we're using this here, mixing it with a polymer and some conductive carbon, and we mix it in such a way that we get these granules. And we do these granules because we want to get the whole process dust-free. So we can take that, put it in bags, or we can put it on a conveyor belt, you name it, no dust. In that, we put this into a so-called pyrolysis reactor, and this is then reacted at a 400-something degrees Celsius, and then comes this material out. And this is then our cathode active material. So no metal in there, no manganese, no cobalt, no nickel, nothing from China. We take this material, we can then coat that on the anode material, the current collector, which is an aluminum foil, either wet or even better, we can do it in a dry process. So that's why we're very convinced it's number one, a environmentally very, very friendly technology, but also from a cost point of view. Rock bottom, no materials coming out of China.
And what does the energy density look like in a product like this?
So right now we're at about 350 watt hours a kilo. And so our, what we committed on a joint development program with a big auto company is going to be a little bit more than 400 watt hours a kilo by early 2026.
And that's very competitive with what we're seeing in the lithium ion space. So that's really good to see.
And it's definitely a lot cheaper.
Yeah. Oh, so as far as application-wise, you see this just in automotive, or are there other forms that you see this succeeding?
No, it's a lot of other applications as well. I mean, our main target right now is automotive. But we also see that, potential applications in the grid. And the entire grid needs to be remodernized, because this stuff is ancient. But then there's all these other applications. We just had a gentleman here from a trucking company. We had somebody else that had some problems, with some of the warehousing robots that they were using. I haven't seen anybody yet, but they're going to be coming here tomorrow. Probably all these electric aviation guys. They're looking for something that's very high energy density, so they don't have to haul around all this weight. The drone guys. There is bus guys, truck guys. There's so many other applications that I call them not the sexy ones. Everybody wants to talk about automotive, but there is so many other things out there. So many other things out there.
Well, thank you so much for spending some time with us and teaching us about what you have going on here. It definitely caught my eye, and I'm excited to see where you guys go in this space.
Who's Miss GoElectric?
That's right. Now he knows. You're going to be a follower, trust me. Thank you.
All right.
Several companies were debuting new technologies, and many leaders showed their experiences on main stages. This year, companies related to battery recycling were a very common topic. Countless exhibitors focused on the circular economy were present this year. I also noticed several cell and pack companies which I have not yet read about or reported upon. Companies producing small parts, cables, and equipment for workers were all vying for attention. It is clear to me that the U.S. is building serious infrastructure to support the electrification of everything in America. Well, I hope this was a very interesting video for you, and I will put links in the description below if you want to investigate some of these companies a little bit further. But thank you so much for watching, and until next time, drive, fly, ride. Go electric.